Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 5B Part 2 assignment. Okay. First one we're going to take a look at is number 12 here. Find K given the consecutive arithmetic terms. Okay. So 32, K, and then 3, they're all in a row. So just so you can understand this thing really well, let's say we've got a sequence, say 4, 7, and 10. We're adding 3 each time, right? What you can do is you can say, hey, look, 7 minus 4 gives us 3, and so does 10 minus 7 also gives us 3. So then what we can say is, hey, we know that 4 minus, oh, sorry, not 4 minus, but 7 minus 4, this here, 7 minus 4 is going to equal 10 minus 7 equals 10 minus 7, right? Because 3 is going to equal 3. We know that for sure. So we want to use that same idea here. We're going to go K minus 32 should equal 3 minus K. Okay, and then now all we do is solve this thing. So I'm going to add K to both sides and maybe add 32 to both sides. And we get that 2K equals 35. So we divide both sides by 2. And we get K is 17 and a half. Okay? Okay, same idea with E. It's probably a wise idea to put parentheses around these. That's a good way to get it so it doesn't get messed up. So we're going to do, we know that 3K plus 5 minus the quantity 2K plus 7 has to equal 5K minus 4 minus 3K plus 5. And then now what we want to do is distribute that negative through on each one of those collect like terms and solve for K, right? So that's going to be 3K plus 5 minus 2K minus 7, and then 5K minus 4, and then minus 3K and minus 5. Okay, so 3K minus 2K is K, 5 minus 7 is minus 2. 5K minus 3K is 2K, and negative 4 and negative 5 is negative 9. So I'm going to move my K's to the right side and my numbers to the other side here. That's going to give us 7, and that's going to give us equals K, and that's it. That's all we got to do for that. Okay. Also, if you want to check to make sure that these work, it's not a bad idea. You can plug these numbers back in to just double check. So we would say 2 times 7 plus 7 is the first term, and then 3 times 7 plus 5 is the second term, and 5 times 7 minus 4 is the third term. So that's 2 times 7, 14 plus 7 is 21. 21 plus 5 is 26. And then 35 minus 4 is 31, right? So we add 21 plus 5 is 26. 26 plus 5 is 31. So that ends up being a arithmetic sequence, so we know for sure we got that thing right. Okay? All right, let's take a look at 13. Find the general term use of n for an arithmetic sequence with the 7th term being 41 and the 13th term equaling 77. Okay, there's several ways to do this, but honestly, I like to make this chart on here, and I think that this makes this problem, I don't have to memorize any formulas or anything. I just make a chart and I make it work for me. So I'm going to do this. I'm going to do first term, second. I'm going to go all the way up to 13th term. 3, 4, 5. Okay, and I know that on here, we've got our 13th term is 77, and then our 7th term is going to be 41, right? So that's what I'm going to do. I know it looks a little ridiculous, but you will see here in a minute why I do this, okay? So we're going in order to come up with our general term, we're going to need two things. We always need two things. We need the first term, and then we also need the common difference. Okay, right now we don't know what either of those are. We don't have the first term or the common difference. But by making this chart, here's what I do. I know that I'm going to have to take 41, and if I add one difference, it gets me to this number. I add another difference, it gets me to this number. So I'm just going to keep putting plus d's at the bottom of all these lines here. So then I know that 41 plus 1, 2, 3, 4, 5, 6 d's is going to give me 77. So I subtract 41 from both sides so I can figure out what d is. 60 gives us 36, divide by 6. And guess what? Our difference is going to be 6 each time. So now I've got half of the puzzle solved. Now I need to go back and figure out what 1 is, the first term. All right, so we know the 7th term is 41, and we know that we're adding 6 as we go to the right. So guess what's going to happen when we go to the left? We're going to then subtract a difference, which we now know is 6. So we're going to subtract 6. 1, 2, well, let's do this. Minus 6, minus 6, minus 6. Minus 6, minus 6. 1, 2, 3, 4, 5, 6 times. So if we take 41, subtract 6 d's, that's going to give us our first term, right? 41 minus 1, 2, 3, 4, 5, 6. 6 differences will give us the first term. Okay, so 41 minus 6. We know that the difference is 6 here, equals u sub 1. So 41 minus 36 is our first term. So that gives us 5 is our first term. So u sub 1 is 5. Now we have all the info needed to come up with our general term sequence, right? So that's where we would say u sub n equals u sub 1 plus n minus 1 all times d. You don't have to have that memorized. You can write it down somewhere and just use it whenever you need it. So I'm now going to say u sub n equals, my first term is 5 plus n minus 1, and my difference is 6. So now just simplify this equation here, distribute this 6 to both parts here, and we get 5 plus 6n minus 6. So our general term sequence is going to be 6n minus 1. That is the general term sequence for this. Now, if you're like, wait a minute, I don't know if that's going to work, plug it in and see what you get. 6 times 7 is 42, minus 1 gives us 41. 6 times 13 is what? 88? No, 78. Minus 1 gives us 77. So we know for sure we got that thing right. Okay? All right. Moving on to number 17. A luxury car manufacturer sets up a factory for a new model vehicle. In the first month, only 5 cars are made. After this, 13 cars are made every month. Explain why the total number of cars made after n months forms an arithmetic sequence. Well, the reason why is because 13 cars are made every month. So you're adding the same number each and every time, right? So that's why you're adding the same amount of cars every month. How long until the 250th car is made? So in order to figure that out, we're going to need to know have our general term sequence. So that's where we need our u sub n equals u sub 1 plus n minus 1 times d, right? So we know that the first term is 5, okay, and then n minus 1, and we know that our difference, that we're adding 13 each time, so 13 there. So u sub n is 5 plus 13n minus 13. So our general term is 13n minus 8, right? Now, we want to know how long until the 250th car is made. So that 250 is going to go in for that u sub n part there. So we would say 250, when is that going to equal 13n minus 8? So we would add 8 to both sides. 13n equals 258. Divide both sides by 13, and we'll see what we get. So 258 divided by 13, and we get 19.84. So it's going to take basically up to the next month there. So it's going to take about 20 months. So n is going to be about 20 months. Okay, because 19.8 means if we went to 19, we wouldn't have made quite the 250th car. So it's going to be in the 20th month is when we're going to make that, when they're going to make the 250th car. Okay? All right. 3, a farmer has 580 square bales of hay in his shed with a total mass of 9,850 kilograms. Farm has 8 yards of animals. Each day the farmer feeds out 2 bales of hay to each yard. Write an arithmetic sequence for the number of bales of hay remaining after n days. Okay. So let's try to, we got to figure out our u sub 1, and we got to find out our d. Those are the two important things to figure out our for our general term sequence. U sub n equals u1 plus n minus 1 times d, right? So first, our starting amount of bales of hay is 580. Okay, and then now we got to figure out what the difference is. So it's got 8 yards of animals. Each day the farmer feeds out 2 bales of hay to each yard. So that's just going to simply be 8 times 2. Means he's going to go through 16 bales of hay every day, right? So D is 16. Okay, so we can now just use that info there to go through and figure out our formula that we need. Now I'm going to back up a little bit here because it says the farmer has 580 bales of hay in his shed. So really this is U sub O. This is, or 0. This is the starting value. That's not U sub 1. So even easier than using this information here is just say, hey, we know that his general formula is going to be U sub n is going to equal, starts with 580, and then he's going to subtract 16 bales of hay each day, right? So we can write that as, instead of 16D for days, let's do 16N since we're using N here. So this is going to be our formula. If we use this as U sub 1, that's going to mess up our formula. It's going to be off by 16. Okay, so again, this is starting with 580. If you said it's like after the first week he had 580, and then he feeds out 18 bales of hay, then we could use U sub 1 and D, but this is actually easier than using that formula. Okay, so that would take care of that problem. Okay, and then last one, number 4, Valeria joins a social networking website. After 1 week, she has 34 online friends, and after 9 weeks, she has 80 online friends. Find the average number of online friends Valeria has made each week from week 1 to week 9. Okay, so that means U sub 1, it's because it says after 1 week, U sub 1 is 34, and then we know that U sub 9 is 80. Okay, so now we got to figure out the difference here. Whenever I don't know what the difference is and they just give us a couple terms, I really like to make this chart here. So I like day after the first day, second day, third, fourth, I'm going to go all the way up to 9. Okay, and then this is it's just a nice visual way to help me see what's going on instead of trying to calculate. I feel like if I do this, the first day is, sorry, after the first week was 34, after the 9th week there were 80. I can see this, and this can help me understand fairly quickly how to figure out what are the average number of friends, because the average number of friends is going to be our D, is what they're basically asking for. What's it going up by each time? Let's find the average number of online friends Valeria has made each week from week 1 to week 9. Okay, so that means I'm going to add a D here, 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 here. All these little lines here are all going to be D's. So I know that if I take 34 and I add 1, 2, 3, 4, 5, 6, 7, 8 D's, I know that I'm going to end up with 80, right? So subtract 34 from both sides. 8D is going to equal, 46? So we divide both sides by 8, and we get, let's see here, we get 46, divide by 8, and we get 5.75. Okay, so find the average number of online friends Valeria has made each week from week 1 to week 9. 5.75 new friends per week on average, right? Okay, and then part B, it says, assuming that our total number of online friends after n weeks forms an arithmetic sequence. Apparently I chopped off the rest of the problem here. Let's figure out what that is. Okay, found the rest of the question. So assuming that a total number of online friends after n weeks forms an arithmetic sequence, find a model which approximates the number of online friends after n weeks. So here's where we would want to use u sub n equals u sub 1 plus n times, let's see, Control Z, there we go, plus n minus 1 times d, right? So u sub n is going to be, first term we know is 34, plus n minus 1, all times the difference, which in this case is 5.75. So u sub n is 34, plus we got to distribute this 5.75 to each piece here, so 5.75 n minus 5.75. So we get that our general term sequence is going to be 5.75 n, new friends per week, on average. And we take 34 minus 5.75 to get us 28.25. Okay, and that would be our general term sequence. Okay, all right, that's all we have for the 5B part 2 assignment. If you have any questions at all on any of this or anything else, please feel free to ask. Thanks.